So in the ring, there will be high intensity, and in outside there will be no intensity. And it's a common sense, right? Because if I have a waveguide and if I passing the light from this side, so there will be no light. Only inside the waveguide, the light will be there. And this is the, actually the FDD diagram. What you see, the field is maximum in the inside that waveguides. Now, back to our main consumption, that what we are saying, that this transistor is electronic domain, and this is our transistor, what we say in our optical domain. So what actually happens in a transistor? There is a collector, there is a emitter, there is a base. It's a current control device. So when you put some current there, then we'll find that from the collector one flow of current is started. When there is a base current, then the flow of current is started. Same we can assume here. When there is a voltage is there, then this ring becomes out of resonance, and out of resonance means there will be no light inside the ring. That means total light will be going to be passed from input port to throughput port. So same actually equivalency can be seen between these two components. That's why in the switching case, we can use this microring resonator as a key component, which is also said the equivalent of optical transistor. Now, I can say that there is a application. So in all optical logic gates, different kinds of that XOR, XOR, NOR, XNOR, OR, and all the gates we can make using this particular circuit, and we'll see how we are going to do this. And also, we can make this half adder, half structure, substructor, full adder, all these electronic circuit. What can be done using these transistors? All the things can be made using that simple circuit, which is called microring resonator. So there is some brief history when it was first proposed. So it was proposed very much way along that 1969, when they are starting with this microring resonator. That time it was only made of fiber, but nowadays we can make of silicon, and small chip also we can make. And the name micro is there because now we can scale down. It's very small scale of these circuits. Okay, and also you can see that it was NAND gate was proposed in 2003, and more T flip flop, JK flip flop, SR flip flop, all the things will be now proposed using this that microring resonator. Now, I'm just stating out some of the advantages. First of all, thing that why we are going to this. First of all, thing what is the future is coming in this quantum computation. So, but in quantum computation, we need single photon circuits. So for that, our this optical gate circuit is very much important. Even first single photon generation has been made using this ring resonator just last year. So see how much useful this circuit is becoming nowadays. And it will support higher bandwidth. The speed is higher. Moreover, there will be no electromagnetic interference, so that will be interference free. So if there is solar storm and anything stuck there, so for that there will be no operational issue if we can make this using a that optical gates or in optical domain, the photonic circuits. And you can see that the flexible design, you can see they're very simple, right? So one ring is there, one straight waveguide, one coupler, two coupler we can add. So it's absorb very low power, the power consumption is very low, because in the fiber when the light goes, hardly any losses occurs there. And then the size becomes very small. It is very lightweight. So it will be very easy to use, and also integration is very easy. So electronic domain to photonic domain, if you want to integrate it, it becomes very easier using this type of circuits. Okay, now let me just come to our main topic, that what we can do using this microring resonator in the photonic circuits. So this is the basic diagram of our AND gate. In electronic domain, how we make a AND gate? We just connect two transistor in series. In case of OR gate, we connect it in the parallel, right? So here, how this works? Simply we say, if I say A is 1, or A, first we can start with A is equal to 0. So if 0, that means there is no base current is there. So no current will pass here. There will be no current. So at the output, there will be no current. So it will be 0. So unless it doesn't matter B is 1 or 0. So in case of A is 0, so output will be 0. So 0, 0, 0, 0, 1 is also 0. Same goes with now A is 1. So if A is 1, now the current is coming up to this much, and depending on B, if it's 0 or 1, I'll get the output. If B is 0, there will be no output, so it's 0. If B is 1, then there will be output. So it's a simple AND gate. So now how can we make it the same thing using this microring resonator? So let's see the structure. If I can draw the structure like this, now this is my A, this is my B, and here I will correct my output. So in my case, here it was the current or flow of electron for finding out is 1 or 0, but in this photonic circuit, it will be the light. If I get light, then there is 1 high. If I get no light, then it will be 0. Now, I'm just having these two logic, that if it's in resonance, the logic is 0. So if it's in resonance, so logic is 0. If it's out of resonance, then it will be 1. Now see, same circuit, let me find it's possible to realize. Now if I say A is in resonance, so if A is in resonance, that means all light is just going inside to this ring, right? In resonance means light is going inside to my ring. So no light will be left for this waveguide. So at the output, there will be no light. So it will be 0. Same, it doesn't matter B is in resonance or not in resonance. If there is no light coming from this upper section, so output will be 0. So output will be 0. So A 0, B 0, output is 0. Same in this case, A 0, B 1, but output will be 0. There will be no light is coming to my output. Now in the next section, A is out of resonance. So if A is out of resonance, that means in the inside there will be no light. All light will be just coming up to this section. All light is here because A is my 1. Now it depends on B. If B is in resonance, all light will be inside, so there will be no light. So B is in 0, there will be no light at the output. And again, if A is 1, B is 1, then see, if A is 1, that means no light will be inside, so light will just in the waveguide. In same case, if B is equal to 1, so there will be no light inside this ring, all will be just pass through. So then the output will be 1. So here we can find that the output is 1. So this is the realization of AND gate using microring resonator, and you can just understand that all is happening in photonics domain, and these are the called is PIC, photonic integrated circuits. So now we are realizing this AND. Same way we can realize this OR, and now we see that earlier we have studied this Alexander interferometric structure. That structure was there, so that structure is now very useful. Now what happened in the upper arm, we have used one ring, in the lower arm we have used another ring, and we termed it as A for this input A, and for this it was input B. And in case of electronic circuit, the circuit here it looks a little bit complicated, but basically it looks like this. Let's just draw. The circuit is actually like this. So here is my output. Now this is my A, this is my B. So based on that, when anyone, A or B, anyone is high, so the current will pass and I will get my output. So this is the structure in electronics domain for OR gate. In this case, if you want to do it from the photonic domain, same goes here. The light is coming from here, so half of the light will go up in the upper arm, half of the light will be in the lower arm. Now, based on the resonance, when the ring is in resonance or out of resonance, so if the ring is in resonance, so it will be logic 0. That means all light will be just sucked up in the ring. So there will be no light here. But if my lower ring is out of resonance, so all light will just pass through and I will get the output in the uh, get some output in this section. So that will be equivalently, we can say, if it is 0, it's 1, so I will get 1. So if 0, 1, I will getting the output 1. Another, we can just check the last one. If both are 1, 1, then can we get that output 1? Just see, if a first this is 1, that means it will out of resonance, so all light will just pass like this. In lower ring also, if it's in out of resonance, which is 1, so all light will just pass through this, so in the output we'll get some output, the output will be high. Same is happening here, 1 1 1, so there will be output. Like that we can implement OR gate using our microring resonator in photonic domain. Okay. Now let's see the other circuits. Now in this case, what we have done, we have made NOR gate using this microring resonator, and we'll find that the circuit is a little bit different. Other in previous case, what we have used only all pass circuit. That means that this ring there was no another waveguide. In this case, we'll find that there is another waveguide is also there, and also this waveguide is connected with the next rings, that second waveguide. Okay. So this circuit, and this is the electronic equivalent circuit. Okay. Now let's see how this circuit is working. So first, let me again make sure that what was my assumption. My assumption was that in a ring, if light is going inside, so that I will treat as 0. And again, if in the ring there is no light going inside the ring, that means the ring is just passing by, so that will be treated as 1. Now see in this structure, in this very structure, how it works. First case, I am saying that it's A equal to 0, B equal to 0. So if A equal to 0 means my from this thing, light will be inside the ring. So here light will go and it will just trap inside the ring. Now, as there is another waveguide in the ring structure, so what will happen once the ring is there, then it will just leak out some light in that upper structure. So in this upper structure, we'll find there is some light. Again, this light is coming here, and this ring, as it's 0, that means it is going to take all the light from that waveguide. So it's taking all the light from the waveguide, and again it will leak out some of the light. So as it's leaking out some of the light, so if there is a photo detector which is treated as the sensor of my structure, PIC structure, now I'll get the output as high, which is 1. So we'll find that the output is 1. So this is the working of NOR gate using that 2 microring resonator. Now let's see, can we just go for another condition? Let's just go for the second condition. Now in second condition, the logic was that if A is equal to 1, so it will be comes under this. That means that inside the ring there will be no light. So now as it's 1, so light will just pass through. It will not going to serve inside this ring. As there is no light inside the ring, so in this structure there will be also no light. As there is no light here, so in the ring also there will be no light. As there is no light here, so there will be no light in this structure. As there is no light here, so in the photodetector there will be no light, so there will be no output. So it will be 0. So here we can see that the output is 0. So this is actually basic structure how we are going to work as NOR gate. So I can explain the other also, but it's also counterintuitive that how this logic will work. And also we can go for the last one, when there will be 1 and 1. So same thing, if there is a anytime there is a 1, so the it's passing through. So in the structure there is no chance to getting any light in this output port. Okay. Okay, another logic you can see what is going to happen when there is 0 and 1. So if there is 0, so as per our this convention, light will be inside this ring. So when the light is inside the ring, some of the light will be leak out. So it will be in this waveguide. But here we'll find that it's 1. 1 means there will be no light inside that ring. So it will just not going to catch up anything from this waveguide to this ring. So as there will be no light inside this ring, so the output it will be 0. So that we have achieved here. Okay. Okay. Now let's move into the next structure. So in this structure, what we have done, we have made that half adder using that microring resonator, and we'll find that the simple Mach-Zehnder structure is there, only one extra waveguide we have just used for realizing the total structure. Now, another some tweak is there, because we have to get XOR gate in this output. So some tweaking what we've made, I'm just going to explain that section first. That how to achieve XOR gate using this microring resonator structure. Just assume that. So what's the basic difference between OR gate and XOR gate? In case of OR gate, when there is 1 1, in case of OR gate, when there is 1 1, we get 1. But in case of XOR gate, when there is 1 1, we get 0. So the complete structure looks like OR gate. So this